Now we're going to start looking at adding and subtracting rational expressions. Since rational expressions are fractions, we have to use the same rules that we used for fractions. And when we add and subtract fractions, we need least common denominators or common denominators. So that's what we're going to focus on in this lesson. Our key terms: the expression 12x squared y cubed is the least common multiple, LCM, of 6xy squared, 4x squared y, and 2y cubed. And the expression 12x squared y cubed is the least common denominator of the three fractions listed. So now, how do you come up with the least common multiple? So we're going to start with numbers, and you can do either a listing method. So if I have 24 and 30, if I start listing multiples of 24, so our 24 and then times 2 would be 48, times 3 would be 72, times 4 would be 96, times 5 would be 120, and so on. For 30, we're going to have 30. 30 times 2 is 60, 30 times 3 is 90, 30 times 4 is 120. Now I'm going to stop there because I already see what my least common multiple is going to be. It's going to be 120. So that's one method. Another method is to use factor trees or prime factorizations. Sometimes your numbers you're not real familiar with them, so there's got to be another way other than list method. Or sometimes you might have to list a lot of multiples. Well, to avoid that, you could use factor trees. So another way to solve this same problem is to find prime factorizations, or do a factor tree. And again, a prime factorization, you can start off, I started with 4 and 6, you could have started with 3 and 8, it doesn't matter, because in the end you're going to get the same thing. So there's my prime. Now let's look at 30. We have 5 times 6, the 6 breaks down into 2 and 3, and the 5 comes down. Now, how do you find the LCM if you have prime factorizations? Well, I'm a visual person, and I like to use circles to organize my factors. What the overlap is, that's going to represent what they both have in common. So that's where I like to start. So they both have a 2. So I'm going to cross a 2 out of each one and put it in the middle. And they both have a 3. I'm going to put everything else in. And now my LCM is going to be everything that I see multiplied together. So I know 2 times 2 is 4, 2 times 3 is 6, then I have a 5. So it looks like my LCM is 4 times 6 times 5, which is 120, which we already knew because we found it doing the list method. So here's two different ways for finding the same information, finding your LCM. Sometimes you can just look at the numbers and you know, but sometimes it is easier to just list or to do the prime factorizations. Now what happens if you have variables involved? How will that affect your LCM? So again, 10x cubed, I'm going to go ahead and just break that down. That's going to be 2 times 5 times x times x times x. And then 30x to the 5th is going to be 5 times 6, but 6 breaks down, so I'm going to have 5 times 2 times 3, and then I have times x times x times x times x times x. So now my circles. Let's see what they have in common. So I'm going to start with my numbers. They both have a 2 in common. They both have a 5 in common. They also have x's in common, so there's one x, there's another x, and one more x in common. Now what are the leftovers? Well, everything in 10x cubed we've already got accounted for. But when I move over to the 30x to the 5th, I still have a 3, and an x, and another x. So what's my LCM going to be? Everything multiplied together. So 2 times 5 is 10, so I have 10x cubed. And then I have 3 times x, so that's going to be 3x squared. So it looks like my LCM is 30x to the 5th. Now if you compare that back to our original problem, you're thinking, well, our LCM ended up being one of our numbers. That doesn't always happen. This happened because the LCM between 10 and 30 is 30. 30 is the first number that both 10 and 30 go into, so I knew the number part would be 30. If you notice, the x to the 5th, that ends up being the largest exponent between the two. Recall when we were doing factoring earlier and factoring out greatest common factors, we always picked the smaller of your exponents. Well, when you're looking for an LCM, you're going to pick the larger of your exponents. So let's look at what happens when you have 3 terms or 3 monomials and you want the LCM. You don't have to do factor trees and all of that all the time. You can just simply look at it and sometimes decide. So between 3, 12, and 15, you might already know what the LCM is there. If not, focus on the number 15. What are your factors? 15 is 15, 30, 45, and 60. I can stop there because I know 3 goes into 60 and 12 goes into 60. So part of my LCM, or the number part, is going to be 60. Now let's look at the x's. If you look, in the first one I don't have any x's, in the second one I have x squared, and in the third one I have a single x. Remember we said that you have to go with the largest that you see, the largest exponent that you see. So x squared. And then finally let's look at our y's. Y cubed, y4. Well, what's the largest exponent? y4. So there's my LCM, and I didn't really do, I did a small list, but I didn't do a large list or multiple lists. I didn't do my prime factorizations. So once you get comfortable with your LCMs, you really don't have a lot of work involved. Now this next one looks a little tricky. We have 5 times t plus 7 and 45 times t plus 7. Well, hopefully you know right away that they have a t plus 7 in common. So that's definitely going to be part of your LCM, is what they have in common. In fact, if you did your 2 circles, just to give you a visual here, t plus 7 would go in the middle. It's a factor because it's got parentheses around it, and then we still have the 5 and the 45. Well, 5 and 45 actually have something in common. They have the 5. And then if we factor 5 out of 45, we're left with 9. So you can kind of see what our LCM is going to be here. If you multiply everything that you see together, 9 times 5 is 45, and then we have that t plus 7. Now, could you go ahead and distribute that? You might. It depends on what the directions are telling you to do. This may be accepted as a final answer. They may or may not consider that to be simplified in my math lab. So just make sure you read the directions so that you have the proper form there. But 45 t plus 7 would be our LCM on that problem. Now let's look at this very bottom one. We have x plus 10, and x minus 10. Now you might be tempted to say that, oh, they all have an x in common. No, they don't. Okay. The first one, we have an x. This is an x plus 10. They're being grouped together. Okay, x plus 10. You can't pull that apart. They don't have any factors in common. Factors are things being multiplied together. So remember, sometimes when you're dealing with numbers, your least common multiple is simply going to be all of your factors multiplied together. That's actually what's happening here. The LCM is just going to be everything multiplied together. Final answer.